Hello everybody, and welcome to Algebra 2, Learning Target 6, Quadratic Functions. Our learning objective is going to be able to, given a graph, students will be able to find the vertex, the axis of symmetry, minimum value or maximum value, the y-intercepts, or the x-intercepts. So these are called the characteristics of a quadratic. The characteristics of a quadratic. So usually would be graphing a quadratic or graphing something. Why do we need to know about these characteristics? Because normally we'd be graphing a quadratic. And if I can tell where exactly that the bottom of this parabola crosses in any place. So if I didn't have a quadratic, it wouldn't really be any big deal. I could pretty much draw it anywhere. The only thing that might matter is how wide to open it. But because we want to know exactly when it's going to hit the ground. An object might be up in the air, and when it hits the ground, we might want to know when I'm going to make the most money, where am I going to maximize something, maximize a profit, minimize a profit. We want to know how high it's going to get, how low it's going to get. We need to know where it's going to cross the axis, and that's all of the axes, right? The y-axis and the x-axis. We want to know, is it going to be going upside down, or is it going to be going like a happy face? We want to know how high it would go and how low it would go, the lowest point. Okay, so that's what these characteristics are all about. So the first thing we need is vocabulary. Well, the first thing also, a quadratic, the shape is going to look like what's called a parabola. That's the happy face, sad face. The first thing we're going to care about is the vertex. So the vertex is the point of the parabola where the parabola and the axis of symmetry intersect. Here's the parabola. And we want the point, the vertex is the point of the parabola where the parabola and the axis of symmetry, the green dotted line, intersect. And that is the vertex. So if I were to change things around, it's still going to go right through the vertex, and it's where they intersect. But what the heck is an axis of symmetry? The axis of symmetry is the line about which the parabola is symmetric. It divides the parabola into two mirror images. So for instance, the vertex, and one thing I want you to pay close attention to, if I go over to here and I find the vertex at where my x-coordinate is 3.583, and I find my axis of symmetry, no matter where on that line of my axis of symmetry, look at the x-coordinate. So if I can find the axis of symmetry, meaning it's x equals, in this case 3.583, if I plug that back in to the function, it's going to give me this. Let me show you. So if I change this, and I change this one, it's still going to give me x equals 4.545 and 5.5 anywhere on here. So honestly, I should switch this one with this one. I should know what the axis of symmetry is first and find it first. So an example of the axis of symmetry, it's going to be given in terms of x equals 4, 5, 6, negative 3, 1, negative 1/2. It's an equation of a line. The vertex, we're going to need to know what the x-coordinate is. So above, it would have to be the same as whatever the coordinate from here was. It has to be. And then the y value is whatever you get when you plug it in. You plug in negative 1/2. I'm going to make it easier. Let's make it 3. That means this has to be 3. They have to match. And the y-coordinate, so you're going to plug in whatever into the function. So let's say we found x was 3. Then what we'd do, and if this was our function up here, we'd basically just rewrite our function. Then we'd replace the notation f of x with a y. Then we said we found that x was y, x was 3. So replace the x with a 3, replace the x with the 3, simplify, simplify again, and that new y value is where the vertex is. That's how you find the vertex. The minimum and the maximum, as we saw, is the top or the bottom of the parabola. It is the highest or lowest point of a parabola, the point at which the function has its maximum or minimum value. So for instance, above we found the vertex was at 3, 2. Well, that's going to be the maximum or the minimum. So we wouldn't write it though as the vertex. We'd write it as the y value, because we care about how high it is or how low it is. That's your y value. So all we need is to do 2. You just write 2. The y-intercepts, there'll only be one. It's the point at which the graph crosses the y-axis. So again, the definition of the y-intercept is where the graph, the red part, the graph crosses the y-axis. The dark one right here is the y-axis, so we care about where they cross. It looks like it's right there. That is the y-intercept. So here I want you to pay close attention. Right here is the function, and what I did was I put in sliders. Now what that means is this a here is a -1. So if I move it, now this a here is now -3.2. So it's just a real quick way to change these numbers just to see what would happen. So I want you to pay really close attention to the c value. So right here is the c value, 2.6. And I want you to pay close attention. I've labeled the y-intercept so that you can always see what the y-intercept is. It's 0, 2.6. The x-coordinate has to be 0 in order for it to intersect up here. So pay attention to this number and to this number at the same time. As I move these, and as I move these. Again, pay attention to the c value here and the y value here. The c value is still the c value, the y value here, c value here as I move this one. So nothing else changes. This c value is super important because all you have to do to find the y-intercept is it's this number. As you change these, that c value does not change. If you change the c value is the y-intercept. The c value is the y-intercept. The c value is the y-intercept, but the x-coordinate always stays 0. So for example, if I use this function here, the y-intercept is, see if you can guess it. So that's a pretty easy one. Easy to spot. X-intercepts. That was the whole idea of solving a quadratic. By, how do you solve a quadratic? There are 4 methods. What are they? And once you solve them, what do you find? You're finding the roots, the zeros, where the graph crosses the x-axis, and you're finding the solutions to the quadratic equation.